Hey guys, today we are talking about matrices. So we've talked about how to solve systems using graphing or using substitution or elimination, but another way that we can solve systems is using what we call matrices. A matrix is a rectangular array of numbers. So you can take your systems of equations and take out just the numbers and make a matrix. So if you're looking at example one, we've got some systems here, and your rows represent equations, and then your columns kind of line up with your variables. So you'll have like a column that's your x column, a column that's your y column, then equals, and the last column, if you're in an augmented matrix, is whatever the number is on the other side of the equal sign. So if I'm going to look at example one right here, my first one is already lined up nicely for me. My x's are on top of each other, y's, and my numbers on the other side of the equal sign. So I can write my augmented matrix. My first row would be 3, then -4, then -6. And my second row would be 2, -3, -5, and that would be my matrix. We label matrices as like rows by columns, so we would say that this is a 2 by 3 matrix because we have 2 rows and 3 columns. When I get to my next matrix for the other part of example 1, it's not lined up quite as nice for us because if you look right here, this number doesn't have a variable attached to it, so it kind of should be on the other side. And if you look at this one, same thing here. So we need to kind of line up and adjust our equations a little bit. Let me change the color here because the yellow pen's not going to be super friendly to write with. Let's do the pink. So I'm going to take my first equation right here, and if I have x plus z minus 1 equals 0, I can add 1 to both sides. So I get x plus z is equal to 1. And if I take this equation right here, where I have x plus 2y minus 8 is equal to 0, I can subtract 8 from both sides, so x plus 2y is equal to 8. So when I make a matrix out of this one, I've got to be a little bit more strategic, a little bit more careful when I make it. I'm still going to have a column for my x's, a column for my y's, my z's, and then whatever it equals over here. So my first equation, I have 2x, -1y, 1z, and it equals 0. With that second equation that I simplified in pink, I have 1x, but there aren't any y's in the equation, so I'm going to put a 0 where the y would go. I've got 1z, and it equals 1 now that I've moved that over. And my last equation, I've got 1x, 2y's. I don't have any z's, so I'm going to put a 0 where the z's would go. And when I moved the 8 over, it's now a positive 8. So my matrix has some zeros where I'm missing some of those letters. So you got to be careful that you don't line it up, even though it looks like it's all lined up, how it's typed out. You've got to make sure that everything lines up properly. Another thing that is somewhat common to see when you have matrices is sometimes people will put a vertical line going up and down where the equal sign would go. So sometimes you'll see that in your matrices, just to kind of show that this is an augmented matrix. So we've got that vocab word right here. An augmented matrix is one where it takes like both sides of the equations and puts them both all together in one matrix. And that's what we're going to spend most of today working with is augmented matrix and how we can use that to solve our systems. And we do that by using what we call row operations. So when we're looking at row operations, there are 3 different row operations that you can use. The first one is that you can interchange any 2 rows. So I could switch like row 1 with row 2 or row 1 with row 5 or whatever, depending on how many rows you have. The second one is that you can replace a row by a non-zero multiple of that row. That's a really fancy way of saying that I could take any row and multiply it by any number as long as the number is not 0. So non-zero multiple of that row. And then 3 is that I can replace a row by the sum of that row and a constant non-zero multiple of some other row. So I could take any row and multiply it and another row and multiply it as long as we're not multiplying it by 0 and add them together and replace the row with that. So that's kind of your 3 different row operations that you can do here. So we're going to look at some row operation examples real quick, just to kind of get familiar with what row operations are. And then we're going to talk about how we can use that to solve our equations on the back page of the notes. Oh, and I forgot example 1, this purple matrix that we have, it's got 3 rows and 4 columns. So this one would be a 3 by 4 matrix if we were to label the size of it. Okay, so looking at example 2, I'm going to zoom in a little bit. We've got a matrix. It has 2 rows and 3 columns. So we would say that this is a 2 by 3 matrix, 2 rows, 3 columns. And we have the very specific row operation that we are going to do R2 minus is equal to negative 3 R1 plus R2. So that's the row operation that we're going to do. So I'm going to start by taking negative 3 times R1. So if my R1 is this first row right here, I'm going to take it and multiply everything in that row by negative 3. So negative 3 times 1 would be negative 3. Negative 3 times negative 2 would be 6. And negative 3 times 2 would be negative 6. Then I'm going to add to it R2, which is my second row. So plus 3 plus a negative 5 and plus 9. So when I do that, negative 3 plus 3 gets me 0. 6 plus a negative 5 gets me 1. And negative 6 plus 9 gets me 3. Now here's the really important part. You got to pay attention. It says that R2, oh, I kind of covered it up, so let me erase that. R2 equals that. So when I rewrite my matrix, it's going to go where R2 was, where row 2 was. So when I rewrite my matrix for my answer, the first row is going to stay the same, 1, negative 2, 2. But now this is going to come and replace where my second row was. It's going to be 0, 1, 3. And that's how we would perform a row operation. It replaced that second row. It changed what my second row was. Let's do some others. In this one, for example 3, we have a 3 by 4 matrix. We've got 1, 2, 3 rows and 1, 2, 3, 4 columns. So this one is a 3 by 4 matrix. We've got 2 different row operations that we're going to do here. So the first one says R1 equals 5R1 plus R2. So I'm going to start with my 5R1. So I'm going to take everything in this first row and multiply it by 5. So 5 times 1 is going to be 5. 5 times 2 is 10. 5 times 6 is 30. And 5 times negative 2 is negative 10. Then I'm going to add to it R2. So R2 is just the second row. So plus 3 plus 1 plus 2. And I'm just going to do minus 8 instead of plus negative 8. When I add that together, 5 plus 3 is 8. 10 plus 1 is 11. 30 plus 2 is 32. And negative 10 and negative 8 is going to give me negative 18 when I add those together. So when I write my new matrix, that is going to go where R1 was because it says R1 equals. So I'm going to come over here, draw my matrix, big bracket bars there, and that's going to go where row 1 would go. So 8, 11, 32, negative 18. Now for my other row operation here, it says R3 is equal to negative 4 R1 plus R3. So I'm going to start with that negative 4 R1. This time I'm taking everything in that first row and I'm going to multiply it all by negative 4. So negative 4 times 1 is negative 4. Negative 4 times 2 is negative 8. Negative 4 times 6 is negative 24. And negative 4 times negative 2 is a positive 8. And then I'm going to add to it this time, do the lighter blue, R3. So R3 is my third row. So plus 5, plus 7, plus 2, and plus 9. So negative 4 plus 5 is 1. Negative 8 plus 7 is negative 1. Negative 24 plus 2 is negative 22. And 8 plus 9 is 17. And this is going to take the place of R3. So I'm going to put that where my third row would go. So 1, negative 1, negative 22, 17. And my second row didn't change, so that's just going to be the original 3, 1, 2, negative 8. And then that matrix that I have there with the purple and the green would be my new matrix after having applied those two row operations. So sometimes it'll specify row operations like this, and you just kind of follow what row operations it gives you. But the whole point of row operations is to help you to solve your equations. So when we're looking at solving using matrices, you use the three row operation rules to manipulate your augmented matrix into what we call row echelon form. So row echelon form is where you specifically want to get a 0 or a bottom triangle of zeros in your matrix. So you want to think about what row operation can I apply here that would get me to this specific format of a matrix. Then once you get to that format, you can put it back into equation form instead of matrix form, and it is a little bit easier of equations to solve than what you originally started with. So let's look at example 4. First thing I'm going to do is go ahead and write my matrix. So if I'm looking at this, my x's, y's, and everything is lined up nicely. So I have 1, negative 8, negative 5, then negative 1, 2, 8, with like the equal sign right there. And what I'm trying to do is I'm trying to get this to be a 0. So when you have your 2 by 3 matrices, 2 rows and 3 columns, you just need that bottom left to be a 0. So if I'm looking at this, I'm going to try and figure out how can I combine R1 and R2 in some way that that negative 1 would become a 0. So I would say the easiest way would be to just add them together. So R2 is going to equal R1 plus R2 because I have a 1 and a negative 1. When I add them together, that'll get me the 0 that I'm looking for. So I'm just going to add them together. So over here, R1 would be 1, negative 8, negative 5. R2 would be the -1, then +2, and +8. When I add them together, that gets me that 0 I'm looking for in that first spot. -8 plus 2 is -6, and -5 plus 8 is 3. So when I rewrite my matrix, the first row stays the same, 1, -8, -5. But now my second row is that 0, -6, 3. So if I were to take that matrix and now put it back as equations, this first row is 1x minus 8y is equal to -5. But my second row, I don't have any x's anymore. Now it's just -6y is equal to 3. So basically what I've done is I've gone through and I've gotten rid of the x in that second equation. So now, to solve that second equation, all I have to do is divide both sides by -6. So y is equal to -1/2. And that was really easy to solve for y right there. Then I can plug it in up here. So I have x minus 8 times -1/2 is equal to -5. -8 times -1/2 is going to be +4. And I can just go ahead and subtract 4 from both sides. So x equals -9. So my answer here would be -9, -1. So when you're looking at matrices, it's an easier way to solve systems. Now you might be thinking, I could have done elimination or substitution really easily on this example. And that's true when you're looking at systems that just have x and y. We talked about that in our last set of notes. It's pretty easy to just do substitution or elimination and solve those. But when you get to problems that look like example 5, where you have x, y, and z, where you get to some more complicated problems, this is where your matrices gets to be really helpful. This is where it gets to make it a lot easier, because when you're looking at these, it's not as easy to just do substitution and elimination. So let's look at one of these. Let's set up a matrix and let's go through some more operations and see what we can do. So if I set up my matrix, remember we need like our x column, y column, z column, and then what it's equal to over here. So for my first one, I have 2x, 2y. I don't have any z's, and then it's equal to 6. The next one I have 1x, 1y, 1z, it's equal to 1. And then 3x, 4y, -1z, it's equal to 13. So when we're looking at these, we need this triangle of zeros. When you're looking at that, the easiest order to do it in is to get this one to be a 0 first, then go to this one, then go to this one. So work your way around the triangle. So I'm going to start with that 3. I want to try and make that 3 the 0 first. And the easiest thing to combine it with is going to be that 1 in my second row. So what I'm going to think about is R3 is going to equal, and I'm going to do R3 minus 3R2. I've got that 1 in that second row. If I multiply it by 3 and then subtract it from my third row, that'll get everything to cancel out. So my R3, my third row, is 3. 4, -1, 13. And then I'm going to take everything in the second row and multiply it by -3, which it's all just ones, so they're all going to be -3. So 3 minus 3 gets me that 0 I'm looking for. 4 minus 3 gets me 1. -1 minus 3 is -4. And 13 minus 3 is 10. So I'm going to rewrite my matrix. Go back up over here. I still have 2, 2, 0, 6, 1, 1, 1, 1. But now my last row is 0, 1, -4, 10. Okay, the next one that I would look at is this one right here. So going right above where that 0 is, I want to try and fix that one. The 0 is not really going to help me. So now I'm going to look at how can I combine row 2 and row 1. I'm going to look at row 2 and row 1. I'm going to say R2 is going to equal, and I'm going to keep R1 as 2, but now I'm going to subtract from it 2R2. I want those to simplify. So R1 would be 2, 2, 0, 6. And when I take my second row and multiply it by -2, they're all going to be -2s. So when I combine that, 2 and -2 gets me 0. 2 and -2 gets me 0 again. 0 and -2 is going to get me -2. And 6 minus 2 gets me 4. So now I'm going to put that where my R2 was. So my first row stays as 2, 2, 0, 6. My third row is still that 0, 1, -4, 10 that I got earlier, but now this row is 0, 0, -2, 4. And then the last one that I want to try and make a 0 is this one right here. But if you look, it has a 0 right above it. And remember, we can just switch rows. That was the first row operation that it said we could do. You can interchange any two rows. You can just switch rows. So instead of trying to multiply it by something or trying to add it to another row, I'm literally just going to take row 2 and row 3 and switch them. So when I rewrite my matrix up here, I'm still going to have 2, 2, 0, 6. But now this row is going to be 0, 1, -4, 10. And the bottom row is going to be 0, 0, -2, 4. That gets me that bottom triangle of zeros that I was looking for. So I'm going to take that, I'm going to write my equations. So my top equation is 2x plus 2y is equal to 6. That middle row, I don't have any x's, so now it's going to be y minus 4z is equal to 10. And my bottom row is going to be -2z is equal to 4. And I can take that bottom row and solve it for z by just dividing both sides by -2. So when I do that, 4 divided by -2 tells me that z is -2. Then I'm going to take that and I'm going to plug it in to my purple equation to figure out what y is. So y minus 4 times -2 equals 10. So that gives me y plus 8 equals 10. Subtract 8 from both sides. So y equals +2. And then I'm going to take that one and plug it in to my equation up here at the very top to figure out what x is. So 2x plus 2 times 2 equals 6. So 2x plus 4 equals 6. Subtract 4 from both sides. So 2x equals 2. And I'm running out of room, but divide both sides by 2 and you get x equals 1. So you can write your answer as an ordered triplet: 1, 2, -2. X, Y, Z. So when you're doing these, you just have to be a little bit strategic about thinking about what row operations are going to be the most helpful for you, and then thinking about what order to get those zeros in that bottom triangle. So it's all about what's going to be the most helpful row operation for me at this specific point. So make sure you get started on your assignment, and if you guys have any questions, let me know. You guys have a good day.